So in this video, I'm going to give a walkthrough of the week 1 lecture for Programming 2. So this lecture is all about introducing you to the unit, introducing you to console applications of Eclipse. So if you missed the lecture, you missed a good one, one of my better ones probably. So we had story time at the beginning where I told a story about my experiences studying programming in my first year, which was about 10 years ago now. So you missed that. That won't be in this video. This video is all about the content. So if you didn't attend the lecture, my name is Lewis. I take quite a few of the programming labs. I'm a postgraduate teaching assistant, which means I do a PhD part-time in the department, and I also carry out various teaching duties. Those are my office hours on the screen there. So I'm based in E113, which is the research office, or one of the research offices. And I've got office hours on Mondays, Thursdays and Fridays. You don't need to make an appointment, you can just turn up to the office or just message me on Teams. So the outline of this presentation is, I'm going to give an outline of the unit first, then I'll talk about console applications, and then I'll talk about how we can make console applications more interactive by gathering user input. So this is the outline of the unit in terms of what we're going to be looking at over the next 6 weeks. So we're inside week 1 now, so it's an introduction to Eclipse and console applications and also gathering user input. Week 2, we'll look at collections, predominantly arrays and array lists. In week 3, we delve into a more advanced subject, which is the topic of inheritance, and we also look at object-oriented analysis and design, which is all about trying to analyze a problem and trying to work out which classes we need and what methods we need inside those classes. In week 4, we'll look at how we can do some file reading and writing, and so how we can handle files. As a side effect of that, we'll be looking at exceptions. You've probably already come across some exceptions in your code. So in processing, for example, you've probably come across a null pointer exception probably more than once. So there's various causes of that. That could be, for example, when you loaded in an image, it couldn't find the image on the disk. You could have also set a reference object to null, and that caused the program to generate a null pointer exception. So we'll look at how we can handle exceptions in week 4. Week 5 is all about graphical user interfaces. So GUIs, we'll be looking at the Swing library there. And then week 6, we're going to be looking at testing. There's going to be an industry speaker in the lecture. That will be an assistant vice president test lead from Barclays. She'll be coming in to talk about the importance of testing, the different types of testing you can perform in your programs. So make sure you attend that one because that's a big deal. So after those 6 weeks of content delivery, we then have a few weeks off for Christmas. You'll probably be working on your assignment during that period, hopefully. And then after those few weeks of Christmas, you come back for your assessment week, which is week 7. That will be early January, and your assignment will be due in that week. So your assignment will probably be handed out in the next couple of weeks, weeks 1 and 2, 2 and 3 even. So weeks 2 and 3, you'll probably get your assignment at about that point. You'll then have a few weeks to work on it during the block. You'll then have a few weeks during Christmas in which you can work on it, and then your deadline will be inside week 7. So the assessment for this unit is a game which is developed in processing, and that game is worth 100% of your mark for that unit. So in Programming 1, you had 4 portfolios, whereas in this unit, Programming 2, you have 1 game which is worth all of the unit mark. You're probably wondering at this point, if the assessment is in processing, why on earth are we bothering with console applications, and why are we going over to another piece of software? So the most obvious answer is you'll be doing quite a few programming related units during your degree. So whether you're software engineering, computer science, cybersecurity, computer games, AI and data science, applied computing, programming is going to stay with you for quite a while. at least until the end of your degree. So we want to sort of step away from the simplicity of using processing, and we need to get used to using a more advanced IDE. And your other units over the next couple of years will be using more advanced IDEs. So processing has about 2 or 3 buttons, play, stop, and debug. Whereas when we look at the IDE we're going to use in this unit, which is Eclipse, there's a lot more buttons. It looks a little bit more, scary. So we need to just get used to that, because it's going to get harder from this point onwards. So in terms of the support you can get for this unit, Dr. Susan Lomax is our program support tutor, and you'll find various links on Moodle under the support section where you can book a one-to-one with Susan, and there's also group sessions where you can book and then she'll walk through perhaps an exercise. You can book these via Moodle, and they are undertaken through MS Teams. Every tutor on this unit who takes a lab will also have office hours, and that is time that they've dedicated to seeing students in the office. The office hours will probably be in their office, but they may also be via Teams, so make sure you double check with your lab tutor. You should be able to find your lecturer's office hours on the Programming 2 Moodle page, and that's when you can expect to find your lab tutor in their office. We also are using the Discord from Programming 1. The link for that is available on Moodle, and that Programming Discord has unit-wide channels where everyone on the unit can speak to each other. So I think there's just under 500 students on this unit. And then we also have lab-specific channels, so channels for each lab. And if you're on computer science, software engineering, or applied computing, we also have channels for computer architecture, which is a unit delivered by Elaine. So Elaine is also in the Discord, so if you're on computer science, software engineering, or applied computing, you definitely want to be in there. These are the stats in terms of the percentage of students per pathway on Discord as of the 9th of November at 6:43 p.m. So you can see there that computer science and cybersecurity, they've got quite a few students in there now. AI and data science, it's not a very big cohort. We've got almost a quarter of them in. Computer games have their own Discord, which is run by their program leader, Matthew Crosley. So I'm not too worried about computer games not joining. Applied computing, if you're on that course, you probably want to join, because at the moment I've got no applied computing students inside the Discord. So if you join the Discord, it's great for getting answers to quick questions, and it saves you having to email and waiting for a reply via email. And lastly, you can also use Teams or email your lab tutor for support, answers to general questions. Discord will probably be better for quick questions. If you need someone to sort of sit you down and discuss something, then you probably want to book a support session with Susan. And if you want to meet your lab tutor, it's probably best to meet them during their office hours. So, like your other units in your other blocks, Programming 2 is a 15 credit unit, and we make the assumption that that is consisting of 150 hours of study. Now, that includes time spent in labs and lectures. So if you take those 150 hours and you divide that by 7, because there are 6 teaching weeks and 1 assessment week, you will get 21.4, which means you need to spend 21.4 hours a week on each unit. So Programming 2 is just one of your units. If you subtract from that 21.4, 1 hour for the lecture and 3 hours for the lab, that means you would be expected to spend over 17 hours of independent study. So there's loads of things you can do in independent study. You can catch up on any outstanding lab exercises. You can complete the extension exercises. You can read. There's some recommended reading on the Moodle sections. There's concept videos on Moodle for you to sort of gain further information about the different concepts we've learned during that week. There are video courses on LinkedIn Learning. There's an almost endless amount of things you can do for your independent study. And that can include, having a support session, because even though I'm saying independent study, it will be predominantly independent, but it will be you doing things off your own back. So that could be attending a support session. That could be visiting your lab tutor in the office to ask them some questions and, walk through some exercises with them. So loads of things you can do. If you're stuck for ideas, just send me a message on Discord and say, I'm looking for things to do to sort of either catch up or gain an advantage or get up to speed. So let's start now with the main bit of the presentation, which is the first topic of Programming 2, which is console applications. So with David in Programming 1, you looked at the fundamentals of programming from a sort of visual perspective, and you did that by drawing shapes and developing simple games in the processing IDE. And the processing IDE just allowed us to use the Java syntax, which are the rules and style of Java, to develop those applications. Now in Programming 2, we're going to take a step back from the sort of visual elements of processing, and we're going to develop console applications predominantly. Now, console applications don't involve a graphical user interface, which means we are more concerned with the logic and less concerned with the aesthetics. That means they're fast to develop and suitable for many common tasks. During my PhD, I've developed loads of little applications, usually to get results for an experiment, and I've probably developed maybe 2 graphical user interfaces, because usually we're more concerned about the results and more concerned about the logic than we are about how the application looks. So in this unit, we're going to recommend you use a popular integrated development environment for developing Java applications, and that IDE is called Eclipse. You are free to use your own IDE. So for example, if you're comfortable with IntelliJ, NetBeans, Dr. Java, you are welcome to use those, but we are going to use Eclipse in the labs. Now Eclipse is very popular in industry for developing Java and Android applications. It's got very good debugging facilities to help us find logic errors in our code and to sort of walk through the code step by step. Because it's a more industry relevant IDE, it's naturally better for managing larger projects. It's very powerful in terms of what it can do, but with that powerfulness comes a little bit of more complexity. So as I mentioned earlier, there's a lot more buttons in Eclipse than there are in processing, so it is quite intimidating when you first open it. But we're going to be providing a sort of an easy introduction for our purposes in terms of what we're using it for. In terms of what you can use it for, there's loads of things you can use it for. So you can write applications which interact with web servers. You can write mobile apps, predominantly Android-based mobile apps. We're going to be writing console apps, but it's also very popular for things like network programming. And Java, it's a very versatile language. There's an almost endless amount of things you can do with Java. Now, all Java code is object-oriented. And when we programmed in processing, we sort of couldn't appreciate that straight away. So in our first couple of weeks in processing, we were introduced to that void setup procedure, and then we were introduced later on to void draw, and all of our code didn't need to be located inside a class. Whereas in pure Java, which is what I'm going to call sort of programming in an IDE, pure Java, all code needs to be contained within classes. So it all starts with a class, and then you'll have methods inside those classes. Now, console applications are not event-driven like most processing programs you make. So in processing, you've got things like void key pressed, void key released. You've got all those different procedures which are listening for those events. Now, console applications are not event-driven by nature. If you add a graphical element to it, then the console application becomes a graphical application, which means you can add things to a graphical application. But a typical console application is not event driven. It's not listening for mouse clicks or key presses. Now, console applications, just like processing applications, they need to know where to start, so which class essentially. So in processing, we know that the execution of the program began in void setup, and then after it finished everything inside setup, it would then go to draw and continuously execute everything inside draw. Whereas in Eclipse, not just in Eclipse actually, in Java, regardless of what IDE you use. So in Java, everything begins with the main method. So we can think of the main method as being fairly synonymous with void setup in processing. Now, when you first launch Eclipse in the lab or at home, you'll be greeted with the version number. So in the labs, I believe we're using the March version of 2021. And when you launch Eclipse, you may be asked to select your directory to use as your workspace. The directory or workspace will just contain projects. Those projects are just folders and they contain your source code. What you'll typically do is each week you'll create a new project inside your workspace. Now for your workspace, you want to select the W drive because the W drive has been specially created for this purpose. If you select OneDrive, you'll likely encounter errors and issues with syncing. That's the word I was going for. So every project you make in Eclipse doesn't have just the code that you've written. It also contains many other types of files, and OneDrive doesn't cope very well with syncing to and from the cloud. So you want to try and limit your workspace to be on the W drive, or you could select a removable storage device such as a pen drive, store your workspace on there, and then just bring it into the labs. You also want to make sure you're backing it up in that case. So if you are using a pen drive to store your workspace, you want to make sure you're backing it up, because if you lose your pen drive, you've essentially lost your workspace. So once you've selected a workspace, Eclipse will open. You will probably see this welcome screen. You can just click the X and cross that off, and you shouldn't see it again. Once you've crossed off the welcome screen, you'll see sort of a blank workspace. So there's no projects in this workspace to begin with. We need to add them to the workspace. So your projects will appear in the Package Explorer when we start adding them. So this left pane over here, that will contain all of your Java projects. You'll typically create one each week, and those Java projects will contain your source code. Now, the first thing what I do is create a new Java project. The easiest way of doing that is just going to File, then New, and then Java Project. And that will get you on your way to creating your first Java project in Eclipse. When you select a new Java project, you'll be prompted with all of these different options. So the first thing you want to do is name your project. So I've called it here My First Project. In the lab, you'll probably call this week 1. The Java version, this should be automatically selected for you. We're going to be using Java 15 in the labs, and that should automatically be selected. Depending on the version of Eclipse in the lab and the version you have at home, you may see this modules section at the bottom. If you don't see it, that's fine. It doesn't affect us. If you do see it, if you do see this module bit at the bottom, you can just untick it, because we don't actually need a module. Modules are outside the scope of this course, but essentially what they are is a way in which we can group packages together. And packages are just folders themselves which contain classes. So a bit complicated, and we're just not going to use them. So once you've named your project, you don't need to select an execution environment because version 15 should be selected automatically. And then if module is there, you just want to untick it, and then you can click Finish. If you do forget to untick the create module info.java file, you'll probably see this pop up. If you do see that pop up, you just want to click Don't Create, because we're not interested in modules. Once you've created that first project, you should then see the project appear in the Package Explorer. and you'll see two things inside the project. The first thing is the JRE system library, or the Java runtime environment. This is just a collection of standard built-in classes that comes with Java that we can make use of in our application. So if you were to expand that drop down and then expand some more levels deep, you'll see loads and loads of packages. Inside those packages, you'll see loads and loads of .class files. Those are classes which the developers at Java have given us for free, and we can make use of those in our applications. In terms of the code that we'll be writing, all of our code will be located in our source folder, which is this src folder you see here. So whenever we create a new class, it will eventually end up here. It will either be directly inside the source folder, or it will be inside a named package. Once we've created a project, we can then go about creating our very first class inside Eclipse. So once we've got our project, the easiest way to create a class is just to right click on the source folder, go to new, and then click class. And then you should have a screen that looks like this. So the source folder is the workspace projects folder. So we're inside our workspace here. Our project is called My First Project, and the source folder is the src folder. You don't need to touch that at all, it's just defaulted to that. We then need to name our class. So remember that class names should begin with an initial uppercase letter, and you can't have spaces in a class name, and every subsequent word inside a class should also have an uppercase letter. Then once you've given your class a name, you can keep this as public. We will cover what these keywords mean later on when we discuss encapsulation and information hiding, but for now, everything we have is just going to be public. And then finally, you want to tick the public static void main checkbox. This will insert the main method into the class, which will allow it to run. So for now, we can just think of the main method as being very similar to void setup in processing. And after all that hard work, we then finally have a class with a main method. When you create a class with a main method in it, you'll see this sort of comments. You can just delete that. It's just a comment which doesn't mean anything. And we can then start writing code. So I should probably explain what this main method is, even though it is quite a mouthful. So we've got these keywords here: public static void main string args. I'm not going to attempt to explain all of this because there are some things in here which require additional knowledge which we gain in the subsequent weeks of programming too. But at a very high level, the word static means that we don't need to create an object of this class in order to call the method. So for example, this main method, we don't need to create a hello world object. We don't need to say hello world HW equals new hello world, because this main method is static. Static means we can call a method without ever creating an object of the class. So it can execute by itself essentially. We know what void means. Void just means it won't return anything. So the main method will trigger the application to start, and by the time it finishes, it won't return anything back to the calling code, because there is no calling code. This is where the program starts. We then have a string array, and I cover arrays next week in week 2. So I'm not going to attempt to explain that. All you need to know is this main method is where our application starts. So we can start by entering statements into the main method. So a couple of statements that we'll get familiar with straight away. One of those statements is print, and that will just simply print a message to the console. And then system.out.println, that will print a message to the console and then move to the next line, so it will add a carriage return. And if you've got an empty print line statement, that will simply just print out a blank line. So if we look at these two statements here, we've got the word hello followed by a blank space. So that first statement here will output hello to the console followed by that blank space that you see there. And then it will stay on the line, so print will print something out and stay where it is. So that first statement prints hello space, then it's currently here where this W is. This second statement will print world to the console, and then it will move to the next line. So you don't actually see that here, but this print ln means when you printed out the word, move to the next line. So if we had a third print statement here, or print ln statement, it would appear just underneath hello world, because that print ln causes the cursor to move to the next line. When you run this application, which is the green play button, which I've cropped out here to sort of save on screen space, once you run the application, which is the green play button, you'll see the output you'll see the output in the console window, and that automatically gets shown when you run the application. So we've seen how we can output some very simple things to the console. Now we should look at how we can make this more sort of interactive by being able to collect user input. So in Java, console applications, we can use streams to handle input and output. So in Java, I/O is handled by what we refer to as streams, so streams of data. Now a stream can come from or go to many different types of data sources. The default is the keyboard, and I'll explain what that means later on when we have the class that we're going to use. But there's many different types of input and output. So you could be reading from the keyboard, you could be reading some data from a file, the data could be coming from a database. There's loads of different types of sources in which a stream can capture. Now, all keyed input, i.e. whatever someone types in, is stored inside a stream. So you can picture a stream as like this sort of tunnel of input. So as they start typing things in, we can extract it from the tunnel. And we'll see how we can do that with a built-in class. And we can retrieve all of that input using various commands. Something else to note is a stream can also contain characters which we aren't really interested in. So for example, 123 space ABC space 12 and then \n. \n means the person has pressed enter and they've moved to a new line. So we're not really interested in carriage returns and spaces usually, we just want the actual data they're giving us. So we also need to look at how we can sort of skip those. Now in order to gather this input, we can make use of one of Java's built-in classes, which is called the scanner class. And let's take a look at that now. So the scanner class is built into Java. Someone else programmed it many, many years ago. That means we don't need to reinvent the wheel. It's already been coded for us. And the scanner class allows us to read input of many different types, whether it's integers, strings, floats. And then as we read the input, we can then do something such as store that data within variables. Now, because we now want to use a class from the Java library, we need to import it into our program. And we achieve that by using what's known as an import statement. An import statement will usually be at the top of the code, and Eclipse and many other IDEs can handle this automatically. Now, there are thousands upon thousands of classes in the standard Java library, and those classes live in packages, and packages are just subfolders in which related classes are grouped together. The scanner class lives in a package called java.util, and the util stands for utilities. So let's have a quick look at how this could work. We have a class here called ScannerDemo. It doesn't need to be called ScannerDemo. I could have called that anything. We then have a main method here, which means the program is capable of executing. And then first thing we're going to do here is create a scanner object. So recall that the new keyword creates an object. So scanner is the name of the class, which is essentially just a data type. We've then named our object something. So I've called this scanner object keyboard, or more specifically, I've called the reference keyboard. You'll learn more about the difference between a reference and an object during this block as well. But for now, I'll just say that I've called the object keyboard. So I've created a scanner object called keyboard, and I've set that equal to a new scanner object. And in terms of creating a scanner, one of the constructors for that class asks you to pass in an input stream. If you pass in system.in, that will correspond to the default input stream, which is the keyboard. So what we're saying here is, create me a scanner object called keyboard, set it equal to a new scanner object, which is capable of listening to things typed in at the keyboard. And as I mentioned before, if we want to use this built-in class, we need to import it. So we are importing from the java.util package the scanner class. If you don't import it, you'll get a compile time error until you do import it. We can then prompt the user to enter a number. So we're just asking the user now for some input. It's important you do that because you need to inform the user what's expected of them. You can't just expect them to know what to type in. So it's always important to prompt the user if they're expected to do something, in this case, type a number. So prompting the user there. And then we've got int number being declared, and it's being set equal to, and then we're using a method which is inside the scanner class called nextInt. What nextInt will do is it will fetch the next integer inside the input stream. So because the input stream keyboard is hooked up to the keyboard, it's essentially going to fetch the next integer entered via the keyboard. So if the user types in 52, that will fetch that number and then store it inside the number variable. So read the integer from the keyboard using the nextInt method, and the nextInt method is part of the scanner class. Something that's really important is when you open up a stream, in this case we've opened up a stream which is capable of listening to input from the keyboard, we should close it. We should always close a stream once we're finished using it to make sure that that process is now terminated. It's probably less important here, but more important if you've got a database connection or a connection currently open to a file, because you want to make sure that as that connection closes, every change you made, for example, if it was a database, you want those changes to take effect. So whenever you open a stream, you should close it when you're finished using it. In this case, I fetched an integer, and that's all I wanted to do, so I've closed the scanner. I've then simply printed out the number entered. So I'm printing out here the string number entered, and then I'm adding onto that the value inside number. So if someone types in 52, this keyboard.nextInt will fetch the 52, store it inside the number variable. So this system.out.println command will print out the characters number entered, and then it will concatenate onto that 52 if the user types in 52. So string concatenation is just the joining of multiple things to make a longer string. So the output of this, if they were to type in 123, it would fetch 123 from the keyboard, store it inside the number variable, and then it will just echo it out to the console. So in that example there, we fetched the next integer that was typed in, but the scanner class has many different types of methods for collecting different types of inputs. So for example, next line will fetch the next line of text, and it will return it as a string. So for example, hi there. The next float will fetch the next floating point number typed in. Next boolean will fetch the next boolean typed in. When you use Eclipse and you type, scanner.next, it will actually give you a list of all the valid methods that the scanner class has. So what we have here is we've asked the user to enter their name, age, and height. The name would be expected to be a string. The age, we'd expect that to be an integer, a whole number. And the height would probably be a floating point value. So for example, how many meters are there in terms of how tall they are. So if we look at this piece by piece, the first input would expect a string, and we've passed it an integer. But what would happen here is it would read that integer, and because it's fetching a string, it would just fetch that integer as a string. So it wouldn't fetch it as a number, it would actually fetch it as a string, so it would be 45 as characters. The second thing we're asking the user is for an age. So in this case, they've passed in 56 space y. The next int method will just fetch the next integer it sees. So it'll fetch 56, and then it won't fetch anything after that because it's satisfied that's an integer. So that's fine. And then when it comes to the third input, we're expecting a floating point number. And because that space y there is still in the input stream, it attempts to fetch that. And you can't store space y inside a float, because a float is something like, 1.8, 2.4, whereas space y is a sort of mismatched as to what it's expecting. So you can see here we've got an exception called an input mismatch exception, which just means you gave it something it wasn't expecting. Now in Lab B of this week, we'll look at various validation techniques we can use to resolve this issue. So the scanner class has some built-in methods for checking to see what the next thing is in the input stream, just to help you not retrieve something if it's not the right data type. So a summary of this lecture, we're moving over to Eclipse from processing. We've covered some very basic console output commands such as print and println. We've touched briefly on the string data type, which is just a sequence of characters bunched together, surrounded in double quotations. We've covered this concept of a stream, which is just encapsulating some stream of data, whether that's going to somewhere or coming from somewhere. And then we've also touched briefly on the scanner class, which is collecting input in our case. And we can collect input from an input stream using various methods of the scanner class. So for example, next int, next line, next float. And we'll see more examples of the scanner class in the lab. And then finally, this table here shows the labs in Programming 1, in addition to the time they took place and the tutor, and what group and what time and what lecture you now have for Programming 2, or what lab group I should say. So for example, if you're in my lab in Programming 1 on Tuesdays 11 till 2, you now have David from 9 till 12 on Friday. So just because you had one tutor in Programming 1 doesn't mean you've got the same tutor in Programming 2. It is technically a new unit, even though the teaching staff is the same. So make sure you attend your new lab on time with the eagerness to code console applications. And if you're still struggling, don't forget to book a support session. And there's also concept videos on Moodle which contain videos about the scanner class in more detail, including input validation techniques. So that's all I wanted to say today, and thank you for watching.